Welcome back everyone. So we're going to have a go today at some questions looking at topic 1.1.1, structure and function of the processor. This first one is asking us specifically what should happen at the fetch stage of the FDE cycle, looking at the different registers and buses. So we always start with the PC, which holds the address of the next instruction, and it's going to copy this value over to the MAR and then send it via the one-way address bus to RAM to actually locate where that data exists. The control unit has an important role to play here. It's going to be sending a signal to RAM to specify that we do actually want to read some information, some data. So we want you to send that back via the data bus to the MDR, which is our next stage. So we're copying any data we find over to the MDR. From this point, we're going to send it to the CIR, where it actually begins the decode stage. But we just want to focus on the fetch stage within this question, so don't go overboard with explaining the entire process, just focus on the fetch stage. Okay, make sure you are specifically mentioning the buses that are used. So we've mentioned the address bus at the beginning, and now we're mentioning the data bus. Okay, and it's copying that over to the CIR like we said. So all three buses are used here, address, control and data. We can also mention as well what the PC needs to do at the end of the cycle, which is just increment by 1 to point to the address of the next instruction. It can also jump as well, but we can assume that it's just going to increment by 1 unless it's obviously told to jump, which would happen in the execute stage. This next question is just focusing on those buses, so the purpose of each of them. Now make sure you do get the name of the bus in the actual answer here. That's what it actually transmits. So the data bus transmits data, as we said, between RAM and the MDR. Also vice versa, it's a bidirectional pathway, so it can send from MDR to RAM if we are writing to RAM. The address bus is transmitting addresses, so the location of data or instructions. Again, it's that one-way path between the MAR and the RAM, the actual locations within RAM. So we just need to say transmits the address or location, we can call it, between the CPU and main memory or RAM. And then the control bus, as we mentioned before in the previous question, this is going to be sending those control signals to other components like RAM to say we are reading or writing. It also communicates with other registers to make sure things are synchronized and working towards the correct timing. So everything knows exactly what it needs to do at any given point. So mark there for each of those, nice and easy. Next question is asking us for features of a replacement processor that would increase the performance. So we need to make sure that we are mentioning the specific change that is actually going to increase the performance. So we can say things like clock speed, but we have to say that it's going to be a higher clock speed. We need to be specific here to get the mark. Same again for those other characteristics. We have to say more cache or larger cache, or we can say more cores as an alternative here. But make sure you are saying what the increase or what's going to lead to the increase in performance. This next one is asking us about the accumulator in the FDE cycle. So for this one, we know that the accumulator stores the result of any calculations that are performed by the ALU, arithmetic logic unit. It can also hold inputs and outputs as well, so if we are interacting with a program, so you may have seen this using the Little Man computer simulator, when we actually input values or output them, they are temporarily held in the ACC. Any conditional branching as well, so when we're using those short mnemonics, BRA, BRZ and BRP for branching, it's testing the result that's held in the ACC, so it's looking at what the value of that currently is to make a decision as to whether we need to branch or jump to a different instruction. Okay, so just adding on there, holding inputs and outputs as well. So you just need 2 points. I've given 3 here, so take your pick which 2 you want to go for. The next question is the program counter. So we've said a lot about this in the previous questions, so we can just repeat what we've said. So it's copying the address of the next instruction. That's what it's holding, the address of the next instruction. So try not to say the address of the data or the address of the instruction. It has to be the next instruction that's going to be processed and executed. Okay, it's copying it to the MAR, like we said, so that's how it interacts with other registers. There's a mark there for that. We've said as well that it increments by 1, so it's always pointing to the next instruction. It assumes that we are working in a sequential manner and go into the next instruction. It could also jump or branch to a particular address. Obviously that would come from a result of one of those conditional branching statements, BRZ, BRP or BRA. Okay, but it's the PC that would be updated to reflect that jump, starting the process again. So again, I've given you four points there, you just need 2. The name of 3 other registers for this next question, so just make sure you are referring back to the other ones that it's already given you. So you're not going to get marks for program counter and accumulator. Let's refer to the others. So MAR for memory address register, MDR for memory data register, and CIR for current instruction register. They all end in R, so it's safe to assume that they are registers. And this final question, so we've got some assembly. We don't really need to actually understand or look at the assembly in much detail. We just need to obviously know what's going to happen to the registers when this command is actually executed. So store count. So we have a memory location 16, also known as count. That is the label that's been given. The value is 9, and that's what we're actually going to store at that memory address. So the value 16 is going to be copied to the MAR. That's the address of the location. The contents of the ACC, which is obviously going to be 9, that's what we want to store. That's going to be copied to the MDR, ready to actually write this to RAM to that location 16, also known as counts. So the value of 9 is then going to be copied into that location, and you can refer to this as location 16 or count. Okay, so again, 2 marks here. I've actually given you 3 points again, so take your pick which 2 you want to go for. Just a very quick look at the mark scheme. If you do want to pause the video just to have a quick look in a bit more detail, look at for any words that are bold or underlined or any of the guidance. Okay, but I'll let you pause. Thanks for watching.